Hello all, welcome to the Counting Where Exam Prep live session. We know that exams are around the corner and it's time to push yourself to study hard and wish to score good. I know that you have focus and ability. I know that you have patience and stability. Your personality has these wonderful virtues. And so we are here to enhance your ability to reach your goal of scoring good and revising your concepts before it's too late. For this, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through chapters, linear equations in one variable, and algebraic expressions and identities from class 8. So let us see some basics from the chapter linear equations in one variable. So what is a linear equation? It is nothing but an equation which has only one variable and the highest power of that variable is 1. For example, here you can say 2x plus 3 equals to 5. What is the variable here? It is x. What is the power of the variable x? It is x raised to the power 1. So, the highest power of the variable here is 1. Let us see one more example. 3m equals to 5m plus 2. Here there are two terms in variable m. And note that the power of both the variables is 1. That's why it is a linear equation. And remember that equation is nothing but a mathematical statement involving equal to sign. So here you can see the equal to signs in both the equations. It can have variables either only on the right hand side or only on the left hand side or both the sides of the equality sign. So on RHS also we can have a variable, on LHS also we can have, or on both the sides of that equation. So I can write 2x plus 3 equals to 5. So this is also a linear equation because it has a variable with power 1. And this is the highest power. Now let us see how to solve linear equation. When it has variable on one side or when it is having variable on both the sides. So for this method, we have step 1 and step 2. First, we need to transpose the constant terms to other side of the equation and solve the equation so obtain to find the value of the variable. Note that solving a linear equation means finding the value of the variable that satisfies that linear equation. So whenever you put the variable as the value of the variable, then you will get it satisfied. Means if you put x equals to 1 here, you have 5 into 1 plus 10, which is equal to 15. That's why x equals to 1 is the solution of the equation 5x plus 10 equals to 15. So solving this equation, when we have variable on only one side, so here you can see 5x plus 10. So x is on the LHS here. So I'll show you how. Here you can see the variable x has power 1, which is the highest power of the variable. So we have 5x plus 10, variable x on LHS, that is on one side. So we transpose the constant terms. What is the constant term here? It is 10. So if we transpose to the right, plus 10 will become minus 10. So we have 15 minus 10, which is 5. Now what we do? We transpose 5. So transposing 5 to RHS, it is multiplied on LHS. So transposing, it will become divided. So we have x equals to 1. Next, let us see how to find solution when the equation has variables on both the sides, that is on LHS as well as RHS. So here we transpose the variable terms to one side and constant terms to other side of the equation. And then what we do, we simplify the terms on both sides. Means we simplify all the variables on one side and simplify all the constant terms on other side. And so we solve the equation so obtained to find the value of the variable. So here you can see we have 5x plus 2 equals to 7x plus 10. Now we are transposing variables on one side. So we are taking 7x on LHS because we have 5x already on LHS. So 5x minus 7x. Then we have 10 on RHS. We have 2 on LHS. So we transpose 2 to RHS. So plus 2 will become minus 2. Similarly, 7x on RHS will become minus 7x on LHS. So we have 5x minus 7x equals to 2x. 10 minus 2 is 8. Transposing 2 to RHS so that we can find value of x, we have minus 4. So you have to take care of the signs here because we are subtracting 7 from 5, we will get minus 2. And I hope you are familiar with like and unlike terms. Here there will be terms with variables having highest power 1. So the terms will have x or m or a. There will be no x square, x cube and so on in this chapter. Let us see how to reduce the complex equation to simpler form. Okay. For example, you can see here 3p plus 1 by 2 equals to 2p minus 3 by 4. Now our aim is to eliminate the denominators by cross multiplication. So here you can see on LHS the denominator is 2. Correct. On RHS the denominator is 4. To eliminate this, we'll cross multiply. We'll cross multiply like 4 will be product with 3p plus 1 and 2 will get product with 2p minus 3. Then we distribute 4 to 3p and 1. So this is distribution of multiplication over addition. So we have 4 into 3p, 12p. 4 into 1 is 4. 2 2s are 4. So we have 2 into 2p as 4. Then we have 2 into 3 as minus 6. So we have to transpose the variables on one side. So we have 12p minus 4p. And on RHS we have 6 minus 6 and plus 4 will become minus 4 or RHS. So we have 8p equals to minus 10. Therefore p equals to minus 10 by 8. Converting this to simpler form means both numerator and denominator should not have any common factor than 1, any other common factor than 1. So we're dividing the numerator and denominator by 2. So here is the solution of our equation minus 5 by 4. Now let us see how to solve a linear equation by reducing it to simpler form. Okay. Step 1 is cross multiplication to eliminate any denominators. Simplify LHS and RHS. Bring all the variable terms to one side and constants to other side. Solve the equation. So here you can say 2x minus 3 equals to 5 into x plus 5 minus 1. Note that 5 is multiplied to x also and 5 is multiplied to 5 also on the RHS. So on LHS will carry the terms as it is, 2x minus 3 equals to, then we multiply 5x plus 25 and minus 1. Again we simplify the LHS. So there is nothing to simplify on LHS. So we carry the step as it is, 2x minus 3. Then we have 5x plus 25 minus 1, which is 24. Then we transpose the variables on one side and the constant terms on the other side. So 2x is already on LHS. We take 5x from RHS to LHS. So 5x will become minus 5x. 24 is already on RHS. We'll take minus 3 from LHS to RHS. So it will become plus 3. So we have minus 3x equals to 21. So we have x equals to minus 7. Now let us see equations having one variable with power 1 can be reduced to linear form. So here you can see 2x minus 3 equals to 5x plus 1 minus 1 can be written as 5x upon 2x minus 1 equals to 2. Whatever I said, is it true? No. These two linear equations are different. Let us take this example. 5x upon 2x minus 1 equals to 2. Here you can see the example. Let us see the steps involved. We have to reduce the equation to linear form by eliminating the denominators. Again, we have to use cross multiplication for this. And then we simplify LHS and RHS and bring all the variables to one side and constant terms to other side. Then we have to solve the equation. So here you can see 5x upon 2x minus 1 equals to 2. We'll transpose 2x minus 1 to RHS, or we can say we are doing cross multiplication. Here the denominator we cannot see, but it is 1. So we cross multiply 1 to 5x, so it will be 5x again. Then 2 into 2x minus 1. Correct? So we have here 5x equals to 2 into 2x 4x minus 2. So 5x minus 4x equals to 2. That's why we have x equals to 2. Let us see what are algebraic expressions. This is our second chapter, algebraic expression and identities. An algebraic expression is formed using variables and constants and combined using different operations. So here you can see this is an algebraic expression because it is formed using variables x, y, and a, and constant 2. Okay, this constant is nothing but the numeral coefficient of the variable ya. Here you can see the constant is 6. Okay, constant term means a term having no variable or term having variable with power 0, because any variable raised to 0 is 1. Okay, so here we have 9ay square plus 6, 2k plus 4m. Here the variables involved are k and m. Here the variables involved are a and y. Okay. So whenever we are combining variables and constants using different operations like addition, and here you can see in each term there is a hidden multiplication or product. So whenever we say 2x, it is 2 into x. Whenever we say 2ya, we say 2 into y into a. Whenever we say 9ay square, we have 9 into a into y, and so on. Let us see addition and subtraction of algebraic expressions. So whenever we are taking addition of algebraic expressions, we have to add the like terms. Okay. So which are the like terms? For example, here we have two expressions, 3b plus 2ay square and 7b plus 2y. Now you have to ignore the numerical coefficient. Means in the term 3b, the numerical coefficient is 3. And you have to note the algebraic coefficient. So it is b. And for this term, we have ay square as algebraic coefficient. Numerical coefficient is 2. For second algebraic expression, we have b as numerical coefficient and y as numerical coefficient. So here we are observing the algebraic coefficient. Okay, so we have 3b and 7b as like terms. So we'll add 3b and 7b. So 3 and 7 is added and b is written. So we have 10b. Other two terms do not have any numerical coefficient. They do have numerical coefficient, but the algebraic coefficients are not same. Here we have y and here we have ay square. So we cannot add them. We cannot add unlike terms. So we have the final answer as 10b plus 2ay square plus 2y. Okay. Next we'll see subtraction of algebraic expression. It is same as how we are adding the like terms. Here we are subtracting the like terms. Okay. So here we can see you have to be careful when there is a minus sign outside the bracket. So we are subtracting 2b plus 2ay square from 7b plus 2y. Correct? So we will write 7b plus 2y in one bracket and minus 2b plus 2ay square in another bracket. Once we open the second bracket, we'll have minus 2b minus 2ay square. Now let us find the like terms. We have 7b and 2b as like term. So 7b minus 2b is 5b. We'll write 2y as it is and 2ay square as it is along with their signs because they are unlike terms. Okay. Let us see multiplication of algebraic expressions. Monomial by monomial. So monomial is nothing but an algebraic expression having only one term. So when we are multiplying a monomial by monomial, we have to multiply the numerical coefficient of one by the numerical coefficient of other and multiply the variables of one by that of the other. So numerical coefficient for the term phi xy is 5. Numerical coefficient for phi a is 5. So 5 into 5 will give you 25. Then we multiply the variables of 1. So we have x into y here and a for the second term. So we have a xy. Let us multiply a monomial by a polynomial. So here you can see 3a is a monomial because this algebraic expression has only one term. And 3ab plus 6c is a polynomial. So here we have to perform multiplication of monomial by each term of the binomial by a monomial. So the term in the second bracket, there are two terms. An algebraic expression having two terms is called nothing but a binomial. So here we are multiplying a monomial by a binomial. So we multiply each term of the binomial by the monomial. So we have 3a into 3ab plus 3a into 3c, 3a into 6c. So again multiplying the numerical coefficient, we have 3 into 3, 9 and a into a as a square into b. So we have 9a square b. Here we have 6 3s are 18 and a into c is ac. Let us see how to multiply a polynomial by a polynomial. We have to multiply each term of given polynomial by each term of the given polynomial to get the product. So here you can see the polynomial in the first bracket has two terms, whereas that in the second bracket has three terms. So first we multiply 3ab, which is the first term of the first bracket, to the three terms of the second bracket or all the terms of the second bracket. So first term of first bracket into second bracket. So here we go 3ab into 3a plus b plus 2c. Then we write plus 6c into the same bracket. So 6c into the same bracket. Then what we do? We multiply 3ab to each and every term of the bracket given here. So we have 3 into 3, 9, a into a square and b Then we have 3ab into 3, which is 3 into 3, 9. AB will be retained. Then we have 3 into A, B into B. So 3 into 2, first multiplication of numerical coefficients. 3 into 2 is 6. AB into B is AB square. Then 6C into 3, which is 6 3s are 18. A into C is AC. Then 6 3s are 18. C. Then we have 6 2s are 12 and B into C, which is 12 BC. Now let us see how can we multiply binomials using identities. Note that binomials can be multiplied using identities. So here we have some identities. A plus B into A plus B will give you A square plus B square plus 2AB. A minus B into A minus B, which is A minus B whole square, will give you A square plus B square minus 2AB. So if you have y plus 3 means sum of the two terms multiplied by sum of the two terms. Okay, and they should be in brackets. So we can write it as square of the first term plus square of the second term plus 2 times into 2 times the product of the two terms. So we have 2 times y into 3. So it will be 6y. Here, square of the first term a square, square of the second term 4. Then we have minus 2 into a into 2. So we have 4a. But if the binomials are of the form a plus b, a minus b, means the product of sum of two terms and difference of two terms. So order is important. First it should be a plus b. In the second bracket it should be a minus b, not b minus a. Then you have to use the identity a square minus b square. For example, here you have subtraction or difference of two terms and sum of the same terms. So we can write square of the first term minus square of the second term. So we have a square minus 2 square, which is a square minus 4. Then we have x plus a, x plus b. Note that the first term in both the brackets is same, whereas the second terms are different. So this can be written as x square plus sum of the different terms a plus b into that first term plus product of that different terms. So here we have y plus 3, y plus 5. So we can write it as square of the first term plus a into a plus b means 5 plus 3, which is 8, into first term, which is y, plus a into b means 3 into 5, which is 15. Let us see some tips and tricks for exams. First is you have to carefully remember what are algebraic equations and algebraic expressions. Algebraic expression is a combination of algebraic terms and constants using mathematical operation like addition, subtraction, multiplication, division. And if you write this algebraic expression with equal to sign and equal to some value, okay, so this will become algebraic equation because I have used equality sign. So an algebraic equation is an equation with algebraic expression, constants and equality sign. So the name equation itself says it has equal to sign. Okay, and expressions are nothing but they are expressing some constants and variables in combination with the operations addition, subtraction, multiplication and division. Also, when you are forming algebraic expressions from a verbal statement, and in the statement, if the statement comes as equals, equals to, is, amounts, represents, the operation used should be equality sign. If the words comes as sum of, added to, or increased by, plus or total, you have to use the operation addition. If you encounter with words like subtracted from, difference of, less than, minus, you have to use the operation subtraction. If you see the words as product of or multiplied by or times, you have to use multiplication in that case. Whereas for the words quotient of, divided by or over, you have to use division. Also, whenever you are solving an equation by transpose method, means the operation, if it is addition on one side, it will change subtraction on the other side. If it is subtraction, vice versa, it will change to addition. If the operation is multiplication, it will get changed to division. And if it is division on LHS, it will change to multiplication. So for example, here we have 4x minus 2 equal to 6. Here we need to transpose 2 to the RHS. So here you can see it is minus 2, correct? So on transposing, what it will become? It will become plus 2. Okay. So as 2 is subtracted, it should be added on RHS. So we have 4x equals to 6 plus 2, 4x equals to 8. Now we want to find the value of the variable x. 4 is in product with x. So on transposing, it will get divided. Correct. So transposing 4 to RHS, it should be divided on RHS. So we have 8 divided by 4, which is 2. Let us see how to solve complex equation. First, you have to reduce the given equation to linear form by eliminating the denominators by cross multiplication. Means you have to crisscross 4 here and 2 here. It will get multiplied, and do not forget to take the terms on inside the brackets. So here we go. We have multiplied 4 to 3p plus 1 and 2 into 2p minus 3. Here know that you are taking these terms inside one bracket. Okay. And not 4 into 3p plus 1. 2 into 2p minus 3. Then we simplify the equation. We multiply 4 to each term of the first bracket, which is 3 plus 3p plus 1. Then we multiply 2 to 2p minus 3 into 2, 6. Now we solve this equation. We transpose all the variables on one side and constants on other side. So 4p on RHS will become minus 4p on LHS, and 4 on LHS will become minus 4 on RHS. So we have 12p minus 4p, which is 8p. Minus 6 minus 4 will be minus 10. So it will be minus 8 by 10 will convert into simpler form, which will be minus 4 by 5. And if you want to check whether your answer is correct, whenever you are solving one equation, then you have to substitute that value again in place of the variable. And you have to obtain the equation and check. For example, let us solve this. Okay, we are transposing 2x. So we have 4x minus 2x equals to 6. So 2x equals to 6 is and x equals to 3. Now let us check whether x equals to 3 is the solution of that equation or not. So we substitute x equals to 3. So we have 4x means 4 into x. So 4 into 3 is equals to 6 plus 2 into 3. Now if you see, 4 into 3 is nothing but 12. Whereas here 3 2s are 6 and 6 plus 6 is also 12. Correct? So in this way we have verified the answer. Now there are some tips that you should remember to solve word problems. First, you have to analyze the given equation and identify what is given and what we must find out. Then we have to relate the known and unknown quantities by forming an equation. Then we have to solve the equation to find the variable. Also, when you're multiplying algebraic expression, note that if the product of two terms have same sign, then the product will be positive. So two terms having same sign, product will be positive. Two terms having different signs, product will be negative. For example, if you want to take a product of minus a into minus b. So both have same sign, minus minus. So the product will be positive, which will be ab. But if you have minus a and b and you multiply these two, they have different sign. One is minus, one is plus. So here we have minus ab. That means we'll get negative product. Also, while multiplying polynomial by polynomial, we need to multiply each term of one polynomial by each term of another polynomial. So this can be done by taking one term from first bracket and then multiplying that term with each and every term of the second bracket. Then we can move to the second term of the first bracket and multiply that term with each and every term of the second bracket, and so on. Also, when you're multiplying terms, remember that we need to multiply the constants and add the powers of variables. So this is very important. Correct? You have to multiply the constant and add the powers of variables. So what are the constants here? 5 and 3. You have to do multiplication. 5 into 3 is 15. But what about x square and x cube? What are the powers? 2 and 3. You should not do 2 into 3 here. You should add 2 plus 3, which is 5. Then we have y into y. So y means it is y to the power 1, y to the power 1. So it will be y into y. So 1 plus 1 is 2. That's why we have y square. So you should not take 1 into 1 here. You should add 1 plus 1. Also, you have to remember these identities. A plus b into a plus b, which is a plus b whole square, is a square plus 2ab plus b square. A minus b into a minus b or a minus b whole square is a square minus 2ab plus b square, or one term square minus other term square is sum of the two terms into the difference of the two terms. Take care while you are using the brackets. Then we have x plus a into x plus b, which is equal to x square plus a plus b into x plus ab. When you are multiplying two binomials which are in the form x plus a, x plus b, and if you have here the signs as positive, positive, then the product will be x square plus a plus b into x plus ab. When you have minus sign for both the brackets, then simply you have to take minus sign in the same result. Or if you have one positive, one negative, one negative, one positive, then the product will be either of this, either this one or either this. So here we have minus sign, or we have minus on both places of the expression. Let us see what are the some common mistakes a student can do. First is equation has always an equality sign between two algebraic expressions, whereas algebraic expression will not have any equality sign. So I think this is very clear. X cube plus 2x minus 5x, it does not have any equality sign, so it is an algebraic expression. Whereas if we take it as equal to minus 4, so equality sign is involved, so it is an equation. Also, by using transpose method, the operation reverses. So addition will become subtraction, subtraction will become addition, multiplication will become division, division will become multiplication. So here 8 added on LHS will become subtracted on RHS, and 2 multiplied on LHS will become divided on RHS. Also, whenever you are reducing equations to linear equation, we are using cross multiplication. And you have to make sure that every term of the polynomial is multiplied by the constant. So here we have constant 2. it should be multiplied with the bracket y minus 3 and y should be multiplied with the bracket 3. So here we have 2 into y minus 3 equals to 3y, transposing 3y and 2y. So here we can see 2 into y minus 3 2 is 6 equals to 3y. Will transpose what? We are transposing either 2y to RHS or 3y to LHS. So here what we have done, we have taken 2y from LHS to RHS, so it has become minus 2y, and minus 6 will be as it is on LHS, so it is minus 6. So we have y equals to minus 6. Also, while writing terms of an expression, the sign should be considered. So when you are writing the terms of expression x cube plus 2x square minus 5x minus 4, the terms will be plus x cube plus 2y square minus 5x and minus 4. So you have to take the terms along with the signs involved. So for that, you can see the left side of that term. So here you can see minus. So it is minus 4. Here you can see it's minus 5. So you can take minus 5. Now, when adding terms or subtracting, having exponents greater than 1, add or subtract only the coefficients and do not add or subtract the exponents. Correct? Here you can see 4p cube, 7p cube. Okay, these two are like terms because both have the algebraic coefficient p cube. So we add the numerical coefficient 4 plus 7 and retain the variable. Okay, we are not adding or subtracting p cube and p cube. So it should not be p cube plus p cube and you should write the answer here. Okay, so it is 11 p cube. Here you can see while multiplying what you are doing. You are multiplying the numerical coefficients and adding the powers of the variable. So 4 into 7 p 3 plus 3. So it will be 28p to the power 6. If you're multiplying a term like this with a term as 7p, then what you do again numerical coefficient ka multiplication and then p cube into p to the power 1. So 3 plus 1 is 4 and q square and q term is missing means it is q to the power 0. So 2 plus 0 is again 2. That's why we have 28 p to the power 4 q square. Also, while using identities, note that the square of the sum of two numbers and the sum of the squares of two numbers are different. Means a plus b whole square is completely different from a square plus b square. Also, a minus b square is completely different from a square minus b square. While multiplying monomial by a polynomial or polynomial by monomial, make sure each term of the polynomial is multiplied by the monomial and apply distributive property. For example, here you can say minus 3t is multiplied to each and every term of the bracket. Whereas in second step, the child has multiplied only with the first term and kept the remaining two terms as it is, which is the wrong way. So here you can see minus 3t into 2x square. So we have minus 3 into 2 is minus 6 tx square plus minus 5 into minus we have plus 15. So t into x dx minus 3t. Also, while you are multiplying a polynomial by a polynomial, make sure each term of first polynomial is multiplied to each term of the second. So first, how we are doing? We have to do 2p plus q into the bracket. So we take 2p into 2x square. Then we take 2p into 5x then 2p into 1. Then what we do, we'll take q. So q into 2x square, q into 5x, then q into 1. So here we have done. Then similarly, you have to multiply the numerical coefficients and add the powers if the variables are same. Otherwise, write them as 2p into 2x square as 4p x square and so on. Let us see some exam tips for this chapter. First is you have to practice a variety of questions from NCERT textbooks, exemplar and other textbooks, also from the previous year question papers. You have to note down carefully the definitions and properties to use them effectively. Then you have to avoid calculation mistakes while solving any equation. Then you have to read the question carefully and understand it. Next, you have to find what is given in the question, what you have to find or solve. So it will help you identifying formula required for the given equation. You should not make calculation mistakes, especially when you're multiplying algebraic expressions. And at the last, you have to check whether you have answered all the questions and sub questions. I hope this session was helpful. And if you want to quickly revise the concepts, practice some extra sums, and also take a quick test, then Counting Well exam prep kit is here. It will help you quickly glance through the major concepts of your chapter. You can also glance through solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Counting Well for their math learning, and even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. Also, stay connected to our channel, Counting Well, and learn more tricks and tips and ways to avoid common mistakes. We will be revising the chapters Data Handling and Introduction to Graphs in our next live session tomorrow on 22nd February at 6:30 p.m. Well, see you in the next session. Until then, keep learning and keep growing. Thank you.